Hello everyone. Today we will be covering the last learning outcome in this introduction to statistics course. So today we will be covering the use of correlation and regression. So in this session, we will cover like what correlation represents, the measure and strength of linear relationship between two variables, and the different values of correlation, basically positive, negative, or zero correlation. We will also look into some of the examples of correlation. Then we will look into what a regression analysis represents. Basically, it is used for investigation of causal relationship. Then we will use, then we will look into the different tests for correlation, which is Pearson correlation and Spearman correlation coefficient. So before going into these tests, let's begin with the key terminologies. The first one is like, what is correlation? So in statistics, correlation or dependence, it basically refers to the relationship between two random variables. So it basically states that to what extent are these variables related. So it defines the strength and direction of the relationship of the variables. So there are different types of correlation coefficient which are used to measure this relationship. It is one of them is the Pearson correlation coefficient, and which assesses the linear relationship between two variables, and the other is the Spearman rank correlation coefficient, which is suitable for non-linear associations. So basically, correlation values, it ranges from -1 to +1. -1, it is possible negative correlation, and the correlation coefficient of 1 indicates a perfect positive linear relationship, whereas a correlation coefficient of -1, it denotes a perfect negative linear relationship, and 0 suggests no linear relationship. So for example, if we find a correlation coefficient of 0.7, we can, between studying hours and exam scores, it indicates a positive relationship, which implies that increase in study time is also related to increase in exam scores. So that is the basic interpretation of correlation. So understanding correlation is important in various fields, especially economics, psychology, natural sciences, because it helps to analyze the relationship between two variables and make predictions based on the data patterns. So it is also vital to note that correlation may not always mean causation, meaning that a strong correlation between two variables does not mean that one variable impacts the other, but instead it essentially represents that both the variables move in the similar or opposite directions. So next terminology is regression. So regression is a statistical technique which is used to understand and quantify the relationship, basically the predictive relationship between a dependent variable and one or more independent variables. So it involves fitting a mathematical model to the data, and which explains the relationship between the variables. So there are different types of regression model, which include logistical regression for categorical outcome and polynomial regression for non-linear relationships. So the whole concept of regression analysis is based on the coefficients of model, which describe the strength and direction of the variables. So basically the predictive relationship. So again, regression also finds use in various fields, which include economics, finance, social sciences, and business analytics, to make predictions or to prepare a regression model to explain the variability in the dependent variable as a result of changes in the independent variables. So we will look into more of these as we move on to other slides. The first one is explaining the concept of correlation. So in most simple terms, correlation, it measures the strength and direction of linear relationship between two or more variables. So it quantifies how change in one variable is also associated with changes in other variables. So it is used to assess the degree to which the variables move together, basically in the same direction or in opposite directions. So it provides insights into data patterns with respect to two variables and the dependencies of the variables. So there are different types of correlation. The first one is the positive correlation. So when two variables move in same direction, they are said to be positively correlated. So in such cases, the correlation coefficient is greater than 0. So it's positive in this case, and it ranges from 0 to 1. Negative correlation. So when two variables move in opposite directions, the variables are said to be negatively correlated. So in this case, the correlation coefficients, it varies from 0 to -1. And there is also few scenarios when there is zero correlation. So basically, when there is no consistent relationship between two variables, they are said to have no correlation. So in this case, the correlation coefficient is close to 0. So the correlation coefficient is the single quantifiable parameter which is used to determine whether the variables are positively correlated, negatively correlated, or there is zero correlation. So it is a value between -1 and 1. So when the correlation coefficient is 1, it indicates a perfect positive correlation. When the correlation coefficient is equal to -1, it indicates a perfect negative correlation. And when the correlation coefficient is equal to 0, it indicates no linear correlation between the two variables. Although there might be other types of relationships which are not captured by R. For example, it could be causal relationship. But for all purposes, if R is equal to 0, that means there is no linear correlation between the variables. And then we have scatter plots. So scatter plots are graphical representation of data points in a two-dimensional variable space. So they are used to visualize the relationship between two variables. The pattern of points in a scatter plot can suggest the presence and nature of correlation. So the scatter plots are often used for like pictorial representation for presenting to the management to understand the variability or the movement of the two variables. For example, spending of marketing budget and social media, social media likes or social media basically attention of the company products. So that can be used to project on a scatter plot. Then next we have the the strength of correlation. So the strength of correlation, it indicates the extent to which the values are closer to -1, 0, or +1. So it is indicated by the correlation coefficient. So the closer the value is to 1, it is called perfectly correlated. And similarly, a value of 0, a value of -1, it is said to be negatively correlated. So a value of 0 suggests no linear relationship between the variables. Then we have causation versus correlation. So this is a very important principle. And there is always a confusion that if there are two variables are correlated, that means there will also be a causal relationship. So which is not true. So correlation, it does not imply causation. Even if two variables are correlated, it does not mean that changes in one variable may lead to changes in others. So other factors and relationships may be at play. Then we have application. So correlation, the concept of correlation is used in many fields, most predominantly in finance, in economics, in psychology, and in other natural sciences. For example, in finance, correlation is used to understand between the returns of different assets in a portfolio. For example, if you have assets of, say, stocks, mutual funds, and gold. So you can plot a correlation between these assets and see how they are related to each other. So ideally, you would not want to have positive correlation assets in your portfolio, you would want to have slightly negative or a zero correlation, so that whatever the market goes, see, if the market goes up, if all the assets in your portfolio are positively related to the market, that is fine. But when it comes down, the same factor will apply in a downtrend also. So you would want to optimize your portfolio depending on your risk and what type of correlation that you would prefer in your portfolio. Then we have Pearson correlation versus other measures. So a Pearson correlation coefficient is the most common measure for continuous variables that follow a linear relationship. However, other correlation measures such as Spearman's rank correlation or Kendall's tau are used for non-linear relationships or ordinal data. So there are different tests for different types of relationship, but at your level, basically you should know that for linear relationship, the Pearson correlation coefficient is the most predominantly used in any field. So next we look into the regression analysis. So regression analysis is a statistical technique which is used to carry out a causal investigation between a set of independent variables and their influence on the dependent variable. So the main objective of conducting regression analysis is to understand how changes in the independent variables, they are associated with changes in the dependent variable. So, so it is widely used in various fields of prediction, inference, and understanding the underlying relationships. The first one is next we look into the types of regression. So the first one is simple linear regression. So in simple linear regression, there is only one independent variable and one dependent variable. So when you are analyzing this scenario, then the mathematical equation or the correlation or the regression equation is a straight line equation, and it is denoted by the formula of y is equal to a plus bx, where x is the dependent variable and y is the dependent variable and x is the independent variable. Remember, whenever x changes, y will change. So, and it is not the reverse case true. So x is independent variable, it can change whatever it wants, but changes in y are dependent on changes in x. And a is the intercept and b is the slope of line. So this is the simple type of linear regression. Next, we have multiple linear regression. So in multiple linear regression, there are multiple independent variables, usually more than one. It is two or more independent variables which are used in multiple linear regression. And the relationship is modeled as a linear equation. So the equation here forms y is equal to a plus b1x plus b2x2 plus bn xn, where y is the dependent variable and x1, x2, x3, x4 are the independent variables. So one of the most commonly used tools for conducting multiple regression is the SPSS, and other statistical tools have also made it easy to conduct multiple regression. Then we have non-linear regression. So linear regression are pretty much simple. You can model them in the form of a mathematical equation and you can conduct a regression analysis. But in some cases, the relationship between variables may not be linear. So non-linear regression allows for modeling more complex relationships using non-linear equations. So this is how, so these are the different types of regression analysis that you need to know. So in regression, the coefficients and parameters, they represent the relationship between the independent and dependent variables. For example, if you have y is equal to 5x, y is equal to 0.5x plus 1.7y. So 0.5 and 1.7 are the coefficients of the regression equation. Then the main assumption. So the main assumption of linear regression is that the relationship between the variables is linear, which means that it does not follow non-linear relationship. So other assumptions include independence of observations, constant variance of residuals, and normally distributed residuals. So what are the residuals? The concept of residuals is the differences between the observed values of the dependent variable and the values predicted by the regression model. So this difference should follow a normal distribution. That is one of the main assumptions of a linear regression model. The analyzing residuals is essential to check whether the model fits the data well. So this is the concept of residual, which is one of the main assumptions in the context of regression analysis. Then we have goodness of fit. So the goodness of fit indicates the strength of the regression model or how well the regression model fits the data. So it is determined using the coefficient of determinant, which is R square, and which explains the proportion of variance in the dependent variable explained by the independent variable. The interpretation. So regression analysis, it provides insights into the impact of each independent variable. So you may note that not all the independent variables have a similar influence on the dependent variable. Some may be positive, some may have a positive influence, some may have a negative influence, some may not be statistically significant. So that is how it is interpreted. So it allows to assess which predictors are significant and quantify the effects. Then applications, so like correlation, also regression is used in a wide range of fields, which include economics, finance, social sciences, healthcare, and engineering for various purposes. So this is used for basically predictive calculation, and it is one of the main components of big data and analytics that is so much used in different industries today. So the types of data in regression analysis, it can be both cross-sectional data, which is data collected at a single point of time, or the time series data, which is data conducted across an extended period of time. So regression analysis, it incorporates both types of data. And limitations. So even though regression analysis is a very powerful tool, and it has also led to like incorporation in various statistical packages, which is used widely across the industry, there are certain limitations also which you need to be aware. The first one is that it is based on the assumption of linear relationship between the variables. And if the relationship is not linear, the model may not provide accurate predictions. So this has to be kept in mind. Additionally, regression does not prove causation. Actually, there is a small error here. It does prove causation, but correlation does not prove causation. It proves only association. Okay. The third section is explaining how to calculate and interpret correlation coefficients. So the correlation coefficient, it involves, like we understood the concept of that correlation is based on the strength and direction of the linear relationship between the two variables. So Pearson correlation coefficient is one of the most commonly used statistical test, which is used for assessment of correlation between the variables. So this is calculated using the formula that such as that 2R is equal to summation of xi minus x bar 2 into summation of yi minus y bar and into 2 into xi minus x bar yi minus y bar. So this is the formula for correlation coefficient. So in step 2, after calculating R, its value is interpreted based on the following guidelines. So if R is equal to 1, then it is a perfect positive correlation. So as X increases, Y also increases linearly. If R is equal to -1, then it is a perfect negative correlation. So as X increases, Y decreases linearly. When R is equal to 0, there is no linear correlation between X and Y. And therefore, it can be interpreted that there is no linear association between X and Y. And when the values lie between 0 and 1, it is a positive or negative correlation of varying strength. The closer R is to -1 or 1, the stronger is the linear relationship. Now, example 2, negative correlation. So, consider a data on outdoor temperature X and ice cream sales Y for a series of days. So, after recording the data and calculating the correlation coefficient, you get R is equal to minus 0.60. So the interpretation here is that there is a moderate negative correlation between outdoor temperature and ice cream sales. So as the temperature rises, ice cream sales tend to decrease. So this is the interpretation. Example 3, no correlation. Suppose if you have the data on the number of pages read in the book and shoe size of readers. So obviously there has to be no relation. So after calculation, you get R is equal to 0.10. So the interpretation is that there is no significant linear correlation between the number of pages read and shoe size. The two variables do not have a meaningful linear relationship. Now, next we look into outlining when to use correlation coefficients. So correlation coefficients, so basically the Pearson correlation coefficient is widely used in statistics and data analysis to assess the strength and direction of linear relationship, like we had already seen in the concept. So when to use correlation coefficients? So exploratory data analysis. So you can use correlation coefficients when you want to explore the relationship between two continuous variables in your data set. So this can help you to identify potential patterns, dependencies, or associations. Next is the hypothesis testing. So you can use correlation coefficients when you have a hypothesis or research question about the relationship between the two variables and the strength of the relationship. So based on the statistically significance of the results, you can test whether there is a statistically significant linear association between the two variables. Next is the variable selection. So you can use correlation coefficients when you need to select variables for regression analysis or predictive modeling. High correlation between two variables can lead to an effect called multicollinearity, which can affect the stability of and interpretability of the regression model. So you may want to exclude one of them. Then quality control and process monitoring. So here correlation coefficients can be used in quality control and manufacturing settings to assess the relationship between process variables and product quality. A strong correlation may indicate that a particular variable is influencing product quality. And we have portfolio diversification. So correlation coefficients can be used in finance to evaluate the extent to which there is a correlation between the assets. So low correlation between assets can help in achieving diversification and managing the risks of the portfolio. And the next application of correlation coefficients is in psychometrics and education. For example, in educational research and psychometrics, correlation coefficients can be used to study relationship between variables such as test scores, student performance, and demographic factors. So, for example, demographic factors, you can assess like people coming from, say, Japan may have score higher in mathematics as compared to students from UK. So that could be one of the ways in which you can use correlation coefficients. Then biological and medical research. So correlation coefficients in biological and medical research can be used to analyze the relationships between variables like dosage and response and biological markers and patient outcomes. So correlation has found significant application in the biological and medical research. Then you have social sciences. So correlation coefficients in social sciences can be used to examine connections between variables like income and education, crime rates and demographic factors, or public opinion and policy preferences. So that is the application of correlation coefficient in social sciences. Then correlation coefficients is also used in market research to investigate relationships between variables such as advertising, spending, and sales, customer satisfaction and loyalty, or price changes and demand. So market research, again, correlation coefficient is used extensively. Then in environmental studies, correlation coefficients is used to explore associations between variables such as pollution levels and health outcomes, temperature and wildlife behavior, or climate factors and crop yields. So this way, a correlation coefficient has also found significant application in the environmental studies. So these are the different ways in which you can use correlation coefficient, though. So therefore, it becomes important to understand the overall concept of correlation as well as multiple regression. So with this, we conclude the unit 1 of the this module. So you will be going through other modules, probably through with other lecturers. So if needed, I will also take a session on how to work on the assignments.
Okay.
Yeah, that'd be really great, Sanjay. Thank you.
Thank you.